Hi everyone, I hope we're all enjoying MakerFest 2020 so far. My name is Caitlin and I'm super excited to be here as a representative of InnPower. And today what we're going to learn all about is this super handy tool called the kilowatt monitor. And so what this tool does is it helps you see exactly how much energy a specific device or appliance is using. And you can then use that information to calculate the money that usage is costing you. So whether you're wondering about how much money an older, inefficient appliance is costing you, you're just curious about your day-to-day usage, or you're looking for opportunities for energy conservation, the kilowatt monitor is a pretty neat tool to play around with. So, to get started using a kilowatt monitor is pretty simple. First, you need to plug the monitor into a standard electrical outlet, and then you can plug whatever device or appliance you're looking to test into the monitor itself. Controlling the monitor happens with these buttons on the top. Today we're going to focus on one button, being the watt button, which is right in the middle. To make sure that your device is displaying the wattage used, you simply need to press the button, and then whenever you plug in your appliance or device, the wattage used will come across the screen. Once you know how many watts a device or appliance is using, you can then use that information to calculate the costs associated with that usage. And this is done through a simple calculation that follows these steps. Step 1. We need to calculate the total watts used. This is done by taking the reading from the monitor and multiplying that by the number of hours the appliance is typically used for. Step 2. We now need to convert the watts to kilowatts. This is necessary since electricity is billed by kilowatt hours. And to do this, we can take the total watts used calculated in step 1 and divide it by 1,000, since there are 1,000 watts for every kilowatt. Now we can figure out the cost, bringing us to step 3. Multiply the total kilowatts used by the cost per kilowatt hour. Now normally there are 3 kilowatt hour rates based off of the time of use periods. But due to the current pandemic, the Ontario government has introduced the COVID recovery rate, which sets our current cost per kilowatt hour at a flat rate of 12.8 cents. The final calculation, achieved in step 3, is your total cost for the time spent using that device or appliance. To demonstrate this more effectively, I'm going to go through a few common household examples and walk you through the process. Let's begin by plugging the kilowatt monitor into a standard electrical outlet. Once plugged in, the device will turn on. We will set it to read watts by pressing the button in the middle. It will read 0.0, and we are now ready to plug in our first appliance and get testing. The first item we are looking at today is a fan, a pretty common object in most houses. Items with multiple settings, such as a fan or a blow dryer, will use different amounts of power depending on the settings selected. As you can see here on this fan, when set to low, it uses 20.1 watts, and when you turn it to oscillate on low, it increases to use 22.7 watts. On high, it uses 41 watts, and when oscillating on high, it uses 43.4 watts. Now, let's get to calculating the cost for using this fan. For example purposes, let's say that we use the fan oscillating on low. This gives us our wattage read of 22.7, and we use it for 4 hours per day. We can now complete step number 1 by multiplying these two numbers, giving us a total wattage of 90.8. Next, we divide this by 1,000 to calculate the amount of kilowatts used, and this equals 0.0908. We can now take this and multiply by the kilowatt hour rate of 12.8 cents to determine the total cost, which works out to be 0.0116. So to run this fan on low oscillating for 4 hours per day will cost you approximately 1 cent. For our next item, we are going to be looking at a lamp. Again, an item pretty common for most households. So once we plug the lamp into the monitor and turn it on, you can see that we get a wattage reading of 32.5. Let's walk through the calculation process again and determine how much this lamp will cost us to use. Let's say we use this lamp for 5 hours per day. To complete step 1 of our calculation, we need to multiply the wattage of 32.5 by the 5 hours of usage, giving us an answer of 162.5 total watts used. Next, we divide this by 1,000 to determine the number of kilowatts used, which equals 0.1625. And finally, we can multiply that by the rate per kilowatt hour of 12.8 cents, and we finish with a total of 0.0208. So to use this lamp for 5 hours, it will cost approximately 2 cents. So for our final example today, I want to cover something known as phantom power. Phantom power refers to the electricity that is drawn by devices or appliances that are left plugged in even when they're not turned on or in use. Phantom power can actually account for up to 10% of your electricity bill, and a lot of people fall victim to this without even realizing it. A really great example for a source of phantom power comes from gaming systems, so something such as an Xbox or a PlayStation. It's very common, out of convenience, for us to leave gaming systems plugged in 24/7, that way we can easily turn them on and off when we're ready to use the system. Unfortunately, that means that the entire time the system is plugged in, even when it's not in use, it's still drawing energy, and that's energy that you're going to be needing to pay for. So let's take a look at phantom power from gaming systems and see how much your system might be costing you. Here I have a PlayStation 4. I'm going to plug this in, but I'm not turning it on, and as you can see, it's drawing 1.7 watts of power just from being plugged in. Since we are talking about phantom power and the idea of always leaving things plugged in even when they're not on or in use, for this example, we're going to say that our PlayStation is constantly plugged in all day long, setting our number of hours at 24. So to complete step 1 of our calculation, we will take the wattage of 1.7 and multiply that by the 24 hours to find that a total of 40.8 watts are used per day. We will then divide this by 1,000 to determine the number of kilowatts used, which equals 0.0408. And now for step 3, we will multiply this by the cost per kilowatt hour of 12.8 cents to figure out that the total cost is 0.0052. So for every day that the PlayStation is plugged in but not used, it will cost approximately half of a cent. And while that doesn't seem like a lot for one day, you have to remember that phantom power costs add up over time. So let's take this cost of half of a cent per day and say that it's always plugged in but never turned on for 1 month. That brings the total cost to approximately 16 cents. To avoid phantom power, make sure that you're unplugging electronics that are not in use. And you can also use smart power bars that come with features such as timers or automatic shutoffs. The kilowatt monitor is a really useful and beneficial tool. It can show you ways you can conserve energy, how you can save some money, and might even show you some appliances that could be replaced by a more energy efficient and updated model. If you're interested in playing around with a kilowatt monitor for yourself, you can borrow one from your local Innisfil Public Library locations in Stroud, Cookstown, Churchill, and Alcona. I hope everyone's had a great time at MakerFest so far. Thank you for taking the time today to learn about the kilowatt monitor with me. I hope it's been a great, informative, and educational fun experience. I'm super excited to be here, and I know we all at InnPower are super happy to be a part of this year's MakerFest, and I hope everyone has a great rest of your day.